This is GCSE Physics, Year 11, Unit 1, Static and Current Electricity, and this is podcast 2 in Unit 1, and this is about current electricity. So we have already met static electricity, and you know that static electricity is a result of friction causing two substances to become charged, one positively and one negatively. Now, whenever you take that charge and you pass it into a circuit, that static electricity, it becomes current electricity. So the first thing we need to learn here is a definition of current. And current is the charge that passes a given point or a point every second. Now, of course, this is physics, and we always have an equation for things, especially things we can calculate. And so we have an equation for charge that connects charge and current. So charge is, we use the letter capital Q, and charge is equal to current by time. So current is, we use a capital I, that's just like that, and T is time. And you need to be very careful. Charge is measured in coulombs, current is measured in amps, but time has to be in seconds. And very often when we switch things on, we switch them on for a minute or for an hour or even for a day. But time is measured in seconds. When you do this calculation, you have to always convert your time into seconds. So this is just a little question. It says a current of 6 amps. So we'll write down, we've got I is equal to 6 amps. And if you have difficulty with these kinds of questions, write everything down first, write down your equation, and then decide what to do. So we've got a current of 6 amps. It's flowing for 3 minutes, so our time is 3 minutes. Now, a minute ago, whenever we looked at our equation, we were told we always had to connect into or convert into seconds. So we're looking for how much charge. So the symbol for charge is Q. So first of all, write your equation down. Q is equal to I times T. I is 6, and time now we have to change into seconds. So it's 3 minutes, and there's 60 seconds in every minute. So that's equal to 6 times 3 6s are 18, so it's 180 seconds. And the answer is 1080. And the unit for charge is coulombs. So you always put a unit in, always put an equal sign, and always underline your answer. Right, series and parallel circuits. Now you know that there are two types of circuit. You've learnt this down the school. The first one is a series circuit, and a series circuit, the current coming from the battery, we always put in current coming from positive to negative. Okay, and the current going from the battery goes through every single part of the circuit and back to the battery again, and that's what a series circuit is. In a parallel circuit, however, when the current comes from the battery, it always comes to a point. Now this bit may not be drawn parallel when you look at it, it could be any shape, but you will come to a point where the current has a decision to make. Does it go this way or does it go this way? So it splits up, okay? So that's how you know that that's a parallel circuit, because the current gets to a place where it has to make a decision. Does it go this way and goes this way? When it gets back over here, it joins up again and back to the battery. So this is the main bit of the circuit here, and these are what we call the branches. So we have branches in a parallel circuit, no branches in a series circuit. The current just goes the whole way round. There's no other way that it can go. Current is measured using a meter called an ammeter, and it has the symbol a capital A in a circle. And it's measured in amps, and we just use an A for short, or amperes is a proper name, which is the name of a French scientist, Henri Ampère. We say amperes, and we shorten that to amps. When measuring the current through a component, the ammeter is always put in series or in the same loop as the component. So if we want to measure the current through our bulb or through our variable resistor, then the ammeter is put in series into that circuit. And to do that, you have to take a little link out of your circuit and put your ammeter in. You can't put the ammeter across the link, otherwise you're measuring your current in parallel and it won't work for you. So it always goes in series. Okay, current in a series circuit, you've done an experiment in the classroom where you put an ammeter into the circuit and you measure the current at different parts of your circuit. And we're going to call them A1, A2 and A3 here. And what you find is that the current in every part of the circuit should be the same. So how much current flows from the battery depends on what components you have in there. If they have lots of resistance, then you're only going to have a small amount of current flowing. If they have very little resistance, then you'll have a larger current flowing, but that current will be the same in every bit of the circuit. In a parallel circuit, however, the current splits up, as we said previously. So the current gets down here and it has a decision to make. Does it go this way or does it go this way? And it joins up again here. Now, how much current goes through each bit depends on the resistance of each bit. You know that resistance is something in a circuit which opposes the flow of current. So if you have a branch here with a large resistance, it's only going to let a small current through. So if we look at this example over here, and maybe I'll zoom in a little bit here for you so that you can see. I'll move this over a bit. Okay, now this is a circuit here, a parallel circuit. You've got 9 amps of current coming from the battery and going back to the battery, but the current splits up, and so you have an option of some coming through here and some going through here. Now you can see it's going to split up in the ratio of 2 to 1. Right, because you've got 3 ohms of current there altogether. But the ratio of 2 to 1, you're going to have more current going through this bit because it's got less resistance. So if we split up our 9 amps into a ratio of 2 to 1, we're going to have 6 amps and 3 amps. But you're going to have 6 amps passing through here and 3 amps going through here. And the reason is because this is much less resistance, it allows far more current to flow through it. And once it gets over here, it joins up again to give you 9 amps again. So current in a series circuit is always the same. Current in a parallel circuit splits up and joins back together again. If, as in this example, the 2 bulbs are equal, then your 9 amps of current will just split equally into 4.5 and 4.5 amps. And join up again, of course, over here.